Ladies and gentlemen, it's good to see you.
Good to see you.
Ladies and gentlemen from Redding, California, this is your friend, the chemistry class. Yo. How are you today?
Great.
So the orbitals are part of a space where you have the possibility of finding electrons. So this is a defined part of a space that if there is an electron, that's where electron would go. You get overlap, you get molecular orbital. In this molecular orbital, what you are going to see is electrons which are shared between both atoms. So that's a covalent bond, except both electrons are coming from one of the two atoms. Are you with me so far? Okay. So I would like to define a property of atoms, which is called electronegativity. Some atoms like electrons more. They pull electrons more than other atoms. Well, let's say you have children, and some of you are closer to your children than the father or the mother. So suppose electrons are children. So some mothers are really close to their children. Some fathers are closer to their children. So atoms, the tendency of an atom to attract shared electron clouds. Riley, no text, please. I want you to be here, present, so we can learn. Thank you. Guys, some atoms have higher attraction. For shared electrons, we call them electronegative. The higher electronegativity, the higher tendency to pull electrons toward themselves. Another word, if I say hydrochloric acid, this is the structure of hydrochloric acid. It's really made by sharing electrons. One is coming from hydrogen, another electron is coming from, sorry, I have to adjust the lighting for the camera. In HCl, hydrogen brought one electron, chlorine brought one electron. They are sharing these electrons. So this is a covalent bond. This is a covalent bond. Guys, look up the table. Look this table and tell me electronegativity of hydrogen. 2.1. And what is electronegativity of chlorine? Between these two atoms, which one is more electronegative? Chlorine. So guys, this means chlorine has larger attraction, larger tendency to pull electron clouds of shared electron toward itself. So I'm showing this arrow. Electrons are attracted to chlorine more. So what is the result? Electron is going to have chlorine is going to have larger electron cloud, and electron cloud means larger negative charge. So we have more concentration of electrons around chlorine. Electrons are spending more of their time around chlorine, and less of their time around hydrogen. So hydrogen has short of electron cloud. We say it has got negative, positive charge. Shortage of negative charge is positive charge. Chlorine, more electronegative, is enjoying more of electron cloud from the shared electron. It has partial negative charge. Why am I writing this sign? This means delta, it means partial. There is not a whole full positive charge here, part of a positive charge. This is not a whole charge of one electron, which is one negative charge. It's partial negative charge. So, guys, I'm going to give you a typical example I'm using. Chemical bond, look at them as bond of marriage. Isn't marriage supposed to be 50-50 sharing? That's ideal, right? At the beginning, hydrogen brought one electron, chlorine brought one electron. They are sharing it together. And they said, we will share everything together. But now hydrogen says, chlorine, didn't you say I'll do 50-50 sharing? How come you have 70% of the electron cloud? I am left with 30% of electron cloud. Chlorine says, I'm more electronegative. I like electron more. Haven't you seen marriages where one of the partners takes over everything and the other partner feels deprived? It's unfair, right? What happens if you have an unfair bond of marriage? What happens? Yes, exactly. Wyatt? Or wait. Wait says divorce. Yes. Guys, hydro. Yes, Will. Thank you. Hydrochloric acid. Hydrochloric acid. Is it a very reactive acid? Is it the acid in your stomach which breaks proteins and other food structure? Yes. Why? Because hydrogen, if it sees an opportunity, it says, chloride, I have had it with you. I want a divorce, breaks the bond. Hydrochloric acid doesn't exist in this form. If you add it to water, it's going to break down. You have H plus and Cl minus. That's why, because the bond is polarized. We call this a polar bond. Polar bond. Do you understand the concept of electronegativity? Unfair sharing of electron clouds. One atom taking more of its share. It's not 50-50 sharing of electron clouds. We call this polar bond. They make the bond break easily. They make the compound very reactive. So how do you know which one of the two atoms are going to have more negative charge? The one which has got higher electronegativity. The lower electronegativity is going to lose electron to the higher electronegativity. So electronegativity is tendency of atoms to pull electrons toward themselves, to pull shared electrons toward themselves. Are you with me so far? Do you have any question? Yes, Santana, louder. Will lose electron to higher electronegative atom. Okay. So guys, using this concept, I'm going to show you how to come up with the formula of a compound. How do atoms react together to make a compound? Last time, you used electron dot formula to predict that nitrogen and hydrogen react ratio of 1 to 3. This is the formula of ammonia. You also, I need 3 of these. You also learned that carbon, and the reason was electron dot formula. Carbon with 4 valence electron reacts 4 hydrogens. React with 4 hydrogens to make CH4. So electron dot formula helps where we have limited number of atoms. But what if there is a molecule, there is nitrogen, hydrogen, oxygen, carbon? What is going to be the bonding? What is going to be the formula of the compound? Formula of bonding geometry determines the activity of chemicals. So I'm going to use a more sophisticated method than electron dot formula, than using at the valence electrons. And that is called Lewis structure. It's really predicting a lot of things that we have seen in action. A lot of things that this method predicted. Then we went to the lab, took the compound, studied the structure. We were able to prove that prediction of this model is working. I'm going to explain that when I talk about that. So guys, number one, Let me give you an example, like NF3. So I'm going to apply this structure to NF3 using what is the structure, what is the bonding when nitrogen and fluorine react together, and we say this compound has a formula of NF3, show me the structure using Lewis structure. Step number 1, it says draw a skeletal structure. Put the unique element in center. Can I say we have only one nitrogen? So that's the unique element. So I have to write nitrogen in center. And then I have more than one fluorine. Those go on the side. So I have 3 fluorine, 3 atoms on the side. That's rule number 1. Are you with me? What if you had more than one unique atom? Place the least electronegative atom in the center. I'll give you an example. In this case, we have only one unique atom that goes in center. If we had 2 unique atoms, look at the electronegativity table. What page can you find electronegativity table? Give me a page number. Let's see who gets the page number first. For a chocolate. It's coming. It's ready. Give me a page number. I'm sorry? 126. Page 126. Guys, do you confirm that?
Yes.
Oh, thank you. That's Wade, and this was Alex. Alex H. So use the table of electronegativity to decide what goes in center if you have more than one unique atom. Next. Rule number 2 says, these are 5 steps that you will be using. You do it in the lab. Count total number of valence electrons. Guys, did we say that valence electrons are used to make bonding, not inner electrons? Count total valence electrons, and that's what atoms bring. That's what atoms bring to make a bond. How many valence electrons in nitrogen? Guys, help me. 5, yes, good job. And I have 3 fluorine. How many valence electrons in fluorine? Group 7, 7, yes. So if I add these 2 together, do I get 26 electrons, yes or no? These are total valence electrons that these atoms are bringing together, yes? And then atoms are going to use these electrons to make themselves happy. What's happiness for atoms? Octet, yes. Good job, Cal. So they will try to have 8 electrons using these total number of valence electrons. So never mind about subtract 1 for positive. I am going to give you that example later on. I know it's not clear right now. I give you a better example. Next step, complete an octet for all atoms except hydrogen. Guys, is it fair to say that hydrogen is looking up to helium? Hydrogen would like to have 2 electrons to become happy. It can never have octet. Hydrogen would always make 1 bond and 2 electrons. That would make hydrogen happy. So, complete the octet. Well, if I want to make a molecule, I must connect these atoms together. Every one of these lines are 2 electrons, 2 shared electrons. Then, complete the octet. Guys, how many electrons on fluorine right now? 1 bond. How many? 2. How many more do I need for fluorine to have 8 electrons? 6 more, right? 6 plus 2 is 8. Fluorine has complete octet. Yes or no? And then here I need 6 as well, and 6 electrons as well. Yes? Am I missing anything? Am I missing anything? Cat says nitrogen. Yes. And many other of you said that too. See, nitrogen has 6 electrons, right? So what do I need to complete the octet? 2 more. Yes? Can I say all atoms have complete octet now in here? Yes or no? Yes. Okay. So guys, now count all the electrons that you needed for completing octet. How many have I used? Can I say I used 8 here? 8, yes? 6 plus 2, 8. 6 plus 2, 8. 6 plus 2, 8. 8 times 3, 24 plus 2, 26. So I used 26 electrons to complete the octet, yes? And we had 26 electrons, which was brought, 26 valence electrons brought by these 4 atoms. If these match together, you're done. What if you were short of electrons? What if you had more electrons? I will explain to you. I'll give you an example. But does this make sense so far? Go ahead, Austin.
Doesn't nitrogen only have 5 valence electrons though?
Yeah, that's what we use. It used to have 5 electrons when it was an atom. You used to have 1 TB before you married. After you marry, you have the refrigerator and cooking ware and everything your wife is bringing with you. So before making a bond, number of electrons is 5. But once they want to make a bond, it doesn't matter. It's a community property. They say, let's put all of our electrons together. Doesn't matter who brought what. And use these electrons for happiness, which means we have 26 community electrons. Let's use them wisely so every atom has got 8 electrons. So it doesn't matter what they bring in. In other words, if you marry somebody, you can't tell, honey, don't watch the TV, it's mine. And your wife wouldn't tell you, don't take anything from the refrigerator, it's mine, right? Or that's my car, and you don't drive it. You share community property, marriage, community property, chemical bonding.